Hey, welcome to the second video on organic chemistry. Today we'll be talking about nomenclature of alkanes. So what is nomenclature? Nomenclature in a nutshell is how we name organic compounds. There are so many different compounds in the world and there's a variety of literally everything. So we need a way of organizing such that we can classify the name of a compound so that we're all in agreement on a single name. So, ignoring all the fluff, the basic gist of it is that you want to start off with substituents, and then you want to end off with the name of the parent chain. So, let's go on definitions first. What is a parent chain? A parent chain is the longest chain of carbon atoms that contains the highest priority functional group. A functional group is a part of the molecule that is reactive. It can lead to actual chemical reactions. You can have many of these in a molecule, but the parent chain is the one that includes the highest priority. We'll talk about all of this in another video, so let's focus on alkanes, which has no functional groups. Let's talk about substituents. I can't speak English, but the substituents are the attachments on the parent chain of an organic molecule. So if you think about it, here's a person. The torso would be the parent chain, right? The skeleton, aka that's what we call it, a carbon skeleton. The substituents would be like the limbs, the attachments. All right, now we got that out of the way. Let's move on to actually naming alkanes. What is an alkane? An alkane is an organic compound that only has carbons and hydrogens. That's why we call them hydrocarbons. The important thing here is that it has no functional groups. It just has carbons and hydrogens, and it has no double or triple bonds. If you see a ring with this description, we call it a cycloalkane, something like cyclohexane. But again, let's focus on this in another video. So for regular straight chain alkanes, we first find the parent chain. Right. So in this case, the longest chain of carbons. So we have 1, 2, 3, 4, 5, 6. If you count it this way, this would be 5. The longest chain would be hexane in this situation. Again, my bad for going a bit forward, but we have different prefixes for different numbers of carbons. So if we counted 6 carbons, we would, again, look at this list, and we see hex. If you had 3, that was the longest, we'll call it prop. And the important thing here is you get the prefix, and then you add an ane to the end. And this would be your parent chain portion. So let's go to the second part, which is the substituents. This is actually the harder part, but I'm sure you get it. I think this is best understood with an example. So I'll just read through this and then let's do this. So first is the same as the parent chain, just replace the ane with an ol. B, number all instances of each type of substituent. You can have more than one instance of a substituent as you have different types of substituents. C, use prefixes if more than one instance of a type of substituent occurs. And D, organize alphabetically, ignoring prefixes like di and tri, and use dashes and commas to separate. Again, all kind of complicated, but let's work it out. So we're given the task of naming this molecule right here. So first step first, find the longest parent chain. So I'm gonna start off, and I'll explain this in a bit later. I'll start off with the wrong way. You start off left and right. This is the wrong way, but count 1, 2, 3, 4, 5, 6, 7. Right? Go this way or that way. But you have 7 carbons as your parent chain. So we already found the parent chain portion. This would be heptane. Now let's take care of the substituents. First, let's count. What substituents do we have? We have methyl groups, and we have an ethyl group. All right, so let's write that out. Methyl and ethyl group. Right, now let's count how many instances we have of it. We have 2 instances of dimethyl, or just two instances of methyl. So we write dimethyl. And where does it occur? Let's see, 1, 2, 3 on the fourth carbon. So we write 4 dash 4, 4 comma 4 dash dimethyl. Notice how I use these. The commas are to separate the numbers, and the dash is to separate the numbers from the letters. Now for ethyl, we see only one instance, so we do nothing about that. But 1, 2, 3, 4, 5 is on the fifth carbon, so we write 5 dash ethyl. Now we organize alphabetically, right? Ignore prefixes like di and tri, so we just start off with M and we start off with E. E is before M, so the way we would organize this in the actual name would be 5 ethyl dash 4 dimethyl heptane. Notice there's no dash between this and this. So this would be the name we would get if we start from left or right. But let's consider another option. Let's try starting over here actually. Starting and ending over here. So now we would have 1, 2, 3. So 3 ethyl 1, 2, 3, 4 dash 4 dimethyl heptane. So that's curious. We have two different names for the same molecule, which is the correct one. So this goes into the next point. If you have two parent chains of the same length with different substituent numberings, choose the one with the smallest substituent number at the first point of difference. Once the tie is broken, just use the one that won. And what does that mean? Well, let's number this from smallest number to the largest number. For the top one, we have 4, 4, 5. Bottom one, we have 3, 4, 5. So let's do a battle comparing which is smaller. So 4 and 3, which is smaller? 3, and then the tie is broken. It doesn't matter if this is, let's say 10 or whatever. Even if this is bigger, doesn't matter. We won the first battle, so we use this name. Alrighty. So yeah, let's keep that in mind, and hopefully you learned something. Thank you.